In this video, we're going to continue developing the foundational ideas we need in order to use vectors in this class, and we'll get to our first actual computation involving vectors. So first, a quick review of what we know so far. In an earlier video, I introduced the idea of the magnitude of a vector and the components of a vector. So the magnitude is the quantity connected to how big we draw the vector. For example, if we use a velocity vector to represent the motion of a cheetah running 30 miles per hour to the west, then 30 miles per hour is the magnitude. If we use a displacement vector to represent a person walking 4 miles to the north, then 4 miles is the magnitude. Okay, now coming to this figure, if this is vector A here, the magnitude of the vector is denoted either just by the letter A by itself or by the letter A with the arrow on top and then between vertical lines. Okay. I form the X component of the vector by starting at the tip of the vector and then dropping a perpendicular down to the X-axis. The segment formed on the X-axis is called the X component of vector A. It's denoted A sub X. When we write a notation like that, A sub X, to indicate the component of a vector, we do not put an arrow on top. The component of a vector is not itself a vector. Another thing to notice here is that the X component falls onto the negative X axis, so we would say that the X component is negative. Okay, as far as the Y component, we go back to the tip of the vector, drop a perpendicular onto the Y axis, and then the segment formed on the Y axis is the Y component of the vector. Since the Y component of the vector falls on the positive Y axis, we can say that the Y component of the vector is positive. Okay, so we've seen all of that in the previous video. I'd like to go over one more thing before we begin our first actual vector calculation. So in your trigonometry class, you would have encountered certain basic trigonometric functions, and there are a few of those trigonometric functions we're going to be using over and over and over in this class. So let me remind you of those. To start, let's say that I draw a right triangle. Okay. So here's my right angle. Now I'm going to go to one of the other two angles of the right triangle, not the right angle, one of the other two, and I'm going to label it theta. Now, once I have labeled this angle as theta, then this is the hypotenuse here, the longest side of the right triangle. And here I have the adjacent leg, which I denote ADJ, and then the side or the leg opposite that angle. I write OPP for opposite. Okay, so I have my angle theta, the adjacent side, the opposite side, and the hypotenuse. Now, perhaps you remember from your trig class that the cosine of the angle theta is defined as the length of the adjacent side divided by the length of the hypotenuse. The sine of the angle theta is defined to be the opposite side, or the length of the opposite side, divided by the length of the hypotenuse. And the tangent of the angle theta is defined to be the length of the opposite side, divided by the length of the adjacent side. Okay, so these are three basic trigonometric functions which we're going to be using over and over in this class. Okay, so now we are ready for our first computation involving a vector. Okay, so I'm going to start by just drawing some Cartesian axes. So X, Y, and I'm going to draw a vector A which points into the first quadrant. We're going to say that the magnitude of vector A, denoted just by the letter A by itself, is 7 meters. We're going to say that vector A makes a 55-degree angle with the plus x direction. And from this information, we want to find the x component of vector A and the y component of vector A. So what I'd like to do for these kinds of problems, at least when we are first starting out with vectors, is that, well, first of all, let's illustrate what the x and y components look like. So I'm going to go to the tip of vector A. And then from the tip of vector A, I'm going to drop a perpendicular onto the x-axis. And when I do so, I form the x component here. Then I go to the tip of vector A again. I drop a perpendicular to the y-axis. And then this segment here is the y component of vector A. Okay, so how do we actually calculate the x component and the y component? So what I like to do when we are first getting started with vectors in this course is I like to come in to the figure and I like to draw a right triangle, a geometric triangle like you might have learned about in high school geometry. And I like to draw that geometric triangle so that its hypotenuse coincides with the vector. Okay, so what you're seeing here is that I have the vector A pointing into the first quadrant. I've drawn it in blue, but then in the red, I have drawn a geometric triangle whose hypotenuse happens to coincide with the vector A. So we're going to be using that geometric triangle that I drew in the red as a way of getting the x and y components of vector A. So what I'm going to do is I'm going to take that same triangle and I'm going to copy it as accurately as I can off to the side here. Okay, so I hope that's about the same as that hypotenuse there. And then I'm going to draw in the two legs. This isn't a great match for that triangle, but I hope you get the idea. Okay, so anyways, having drawn this triangle, the length of the hypotenuse, I hope you can see, is the same as the magnitude of this vector. So I'm just going to call the hypotenuse A, same as the magnitude of the vector. Then in here, I have a 55-degree angle. Okay, I hope you're going to agree also that this leg of the triangle has a length equal to the x component. I'm going to call that AX. And this leg of the triangle has a length equal to the y component sub y. Okay, now I can get a sub x and a sub y by analyzing the geometric triangle, which was designed to match the vector A over here. Okay, so how can I get a sub x? Well, I'm going to write down the definition of cosine 55. So cosine 55 would be equal to the length of the adjacent side divided by the length of the hypotenuse. And for this triangle, the length of the adjacent side is a sub x. The length of the hypotenuse is a, same as the magnitude from back here. So if I want a sub x, I just ignore that part in the middle, take the a from down here, move it up to here, and I get ax equals a cosine 55. Okay, now I can substitute a, the magnitude of the vector is 7.00 meters, and then times cosine 55. Okay, Now, remember that when you plug this into your calculator, you should have your calculator in degrees mode. Anyway, what I got when I did this was 4.02 meters. Okay, and we can then get the y component in a similar fashion, except using sine instead of cosine. Okay, so sine of 55 degrees would equal the length of the opposite side divided by the length of the hypotenuse. Okay, looking at the triangle, the length of the opposite side is the same as the y component of the vector. The length of the hypotenuse is the same as the magnitude of the vector. You can see that we can solve for ay here. Okay, so let's say I just cover up that part in the middle and just do algebra on this. Take a, move it up to here, switch sides, and we then have ay equals a sine 55. Okay, so here I plug in the magnitude of vector a, 7 meters, and multiply by sine 55. Again, remembering to have your calculator in degrees mode, we get ay equals 5.73 meters. Okay, so now we have done our first vector calculation using trigonometric functions. We will do many, many, many more of calculations like this by the time we're done with this course.